We are going to take electron beam melting. It is unit 3, photopolymerization and powder bed fusion process. So what is electron beam melting? EBM is a type of rapid prototyping for metal parts. The technology manufactures parts by melting metal powder layer by layer. With an electron beam is a high vacuum. Unlike some metal sintering techniques, the parts are fully solid, wide, free and extremely strong. EBM is also referred as to a electron beam machining. It's a high speed electrons, 5 to 8 times the speed of light are bumped on the surface of the work material, generating enough heat to melt the surface of the part and cause the materials to locally vaporized. It can be used on metals, non-metal, ceramics and composites. So how it works? Electron beam melting. So the schematic diagram of electron beam melting. So dispenses the metal powder in the layer of bed. So across the cross section, high vacuum with a fused electron beam placed on the metal powder. This process is repeated until the part is completed. So the material used in this electron beam melting is stainless steel, titanium, tungsten parts. So also it is used for ideal for medical implants and injection mold. However, it is very expensive process compared to other process. So the cross-sectional view of the electron beam melting process. The fabrication chamber is maintained at high vacuum and high temperature. A layer of metal powder is deposited on the fabrication platform. A focused electron beam is used to melt the powder particles in a small vacuum within the layer. The electron beam is scanned to define two slices of the object within the layer. So per layer it comes sliced 2. The build table is lowered and a new layer of tri-powder is deposited on top of the previous layer. After removal from the machine, the unmelted powder is pressed off and recycled. So this is the schematic view of electron beam melting. Electron beam melting. So it consists of electron beam gun, electron beam powder bed, depositor track, leveling roller. So this is the major components of this electron beam melting. So once again it's the cross-sectional view and description of electron beam melting. So it generates high beam up to 3000 watts. The beam melts each layer of powder metal into desired geometry. So the geometry we are created from the CAD model. The CAD model file is converted to STL file. The STL file is transferred to this 3D manufacturing, that is rapid prototyping manufacturing. So electron beam melting is one of the RPT techniques. Extremely faster beam translation with no moving parts. High beam powder, so up to 800 centimeter cube per H productivity. So vacuum process, excellent material properties, high process temperature up to 650 degrees centigrade. So components making, these are all the components we are making from the electron beam melting. Some collets, machine depositions, some machine parts, components for made for alloys and biomedical components like this. So benefits: high productivity, suitable for very massive parts, more residual internal stress, less supports are needed for manufacturing parts, possibility to stack part on top of each other, sintered powder, process under vacuum, very fine microstructures, EDM drawbacks, so long dead time, track to work with fine powders, expensive maintenance cost. So comparison, electron beam machining versus laser beam machining. So laser beam melting is also one of the RPT technique. So here using electron beam, they are using laser beam. So here using vacuum, they are using argon flow along axis direction. So some specifications based on size, layer thickness, mini wall thickness, accuracy, build rate, surface roughness, geometry limitations, and materials for LBM and EBM. So this is one of the topic for third unit in electron beam welding for additive manufacturing. Thank you.